Good afternoon, everyone. Welcome to the session. We will begin in next 2 to 3 minutes. We are waiting for the session chair to join.
Good morning, ma'am.
Good
Good
morning.
morning.
Good morning, Nishita. Good afternoon. Now it's
Good
afternoon.
afternoon, ma'am. Yes,
Good
we
afternoon.
were waiting for you. Welcome to the
Oh,
session.
so sorry.
That's fine. That's fine.
Yes.
Yes. So
So shall
let's
we start?
begin with the session. Yes.
Yes.
So, hello everyone. A very good afternoon to all of you. Dear authors and all the invited guests, a very warm welcome to Technical Session 8A. Myself, Yashita, and I'll be your moderator for this session. I'll be making sure that everything runs smoothly and maybe try to keep up the energy too. So, on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communications Technology for Sustainable Development, which is ICT4SD 2026. The 11th edition of the conference is being organized in a hybrid mode. So, the physical event was held yesterday in Goa, and the virtual event is being held through Zoom from 9th to 11th July, where people from all over India as well as many from other countries are with us. I hope you all enjoy today's insightful, knowledgeable, and interactive sessions. So, in this session, we will be having a total of 10 presentations, and each presenter will be given 10 minutes for their presentation, followed by 2 to 3 minutes for question and answers. And I will give a gentle reminder at the 8-minute mark just to help everyone stay on track. And it is a strict reminder for everyone that please stick to the time as we are time bounded. So, there is also a small request to all the participants that please stay connected with us till the closing remarks. We promise that the session will be worth it. Also, if you have any queries or updates to give us, feel free to drop them in the chat box. Me and my co-host will be addressing them. So, before we begin, I would like to introduce our session chair to everyone. We have Dr. Ishwari Raskar, ma'am. She is an assistant professor at MIT ADT University, Pune, India, specializing in data science and the IoT, which is Internet of Things. Her sorry. Her research focuses on mobile applications with OCR capabilities, wearable technologies, energy efficient sensor networks, and machine learning based risk assessment. So, Dr. Askar is committed to advancing innovative research and fostering impactful learning experiences for her students. So, ma'am, would you like to say something to start the session?
Yes. Good afternoon, everyone. Good. Thank you so much, Yashita, for a wonderful introduction of me. So good afternoon, everyone. Thank you for giving me the opportunity to present myself, and I'm sharing the knowledge with you. So I am Dr. Ishwari Raskar, Assistant Professor in MIT School of Computing. I have total 10 years of experience in the teaching field. So all the participants performed well and actively participated in the activity. So all the best, everyone. Thank
Thank
you,
you so much,
Yashita.
ma'am. Thank you so much for those words.
Yes.
As ma'am said, we have to make this session as interactive as possible as we are connected online. So not only the session chair, each one of you can ask questions if you have any. So we should begin with the presentations now. So for the first presenter, we have Anusha Hiremat. Anusha, are you present?
Yes, ma'am. Good afternoon, ma'am.
Yes. Good afternoon. So she's here to speak on a review of turbo encoder and decoder techniques for efficient communication systems. So yes, Anusha, you can start.
Sure, ma'am. Ma'am, is my slide visible?
Yes, it is visible. You can go ahead.
Okay, ma'am. Good afternoon, respected session chief, distinguished panel members, professor, researchers, and all the participants. Thank you for giving me this opportunity to present our review paper. I am Anusha M. Hiremat from Department of Electronics and Communication Engineering, Dayanand Sagar College of Engineering, Bengaluru. Today, I am going to present our review paper titled A Review of Turbo Encoder and Decoder Techniques for Efficient Communication Systems. This work was being carried out under the guidance of Dr. K.L. Sudha ma'am. Now let me begin my presentation. This slide presents the motivation behind our work. Reliable communication is an essential requirement in modern wireless communication systems such as LTE, satellite communication, and mobile networks. However, during transmission, signals are affected by noise and interference, which introduce transmission errors. Turbo codes are one of the most effective forward error correction techniques because they achieve performance close to Shannon limit. Therefore, efficient decoding reduces bit error rate and hardware complexity. Now let us move to the problem statement. So this slide presents the problem statement of our review paper. Although many turbo decoding algorithms have been developed, each algorithm has its limits, own advantages and limitations. Some techniques provide excellent decoding accuracy but require higher computational complexity and FPGA resources. Other techniques reduce hardware complexity but slightly compromise decoding performance. Therefore, designing an efficient FPGA-based decoders that balance both accuracy and hardware efficiency remains an important research challenge. Based on this problem, the objective of our reviews are as follows. To study turbo encoder and decoder techniques, to compare different decoding approaches reported in the literature, to analyze their performance in terms of BER, throughput, and hardware complexity, to identify the research gap, and finally to discuss future research directions. Now let us understand the overall turbo coding systems. So this is the flow of turbo coding system. Initially, the input data is applied to the turbo encoder. The turbo encoder introduces redundancy by generating parity bits which improve error correction capability. The encoded data is then transmitted to the AWGN channel, which is additive white Gaussian noise channel, where Gaussian noise is introduced during transmission. Finally, the turbo decoder performs iterative decoding and reconstructs the original transmitted data. Overall, this process improves communication reliability by reducing transmission errors. So this is the overall turbo coding system. Now let us understand each block. Now let us understand the turbo encoder. The turbo encoder, it consists of two identical recursive systematic convolutional encoders connected to an interleaver. As we can see in the block diagram, there are two RSC encoders, one interleaver and one data assembler. So, the first encoder processes the original input sequence. The second encoder, it processes the interleaved version of the same input sequence. The interleaver, it rearranges the input bits, helping to spread burst errors. Finally, the encoder generates one systematic bit stream and two parity bit streams, improving the overall error correction capability. So after encoding, the data is transmitted to the communication channel. So this is the communication channel slide where the encoded signal is transmitted to an additive white Gaussian noise channel. The AWGN channel, it introduces Gaussian noise into the transmitted signal. At the receiver, the received signal is converted into LLR values, which is log likelihood ratio. The system performance, it is evaluated using signal to noise ratio, commonly known as SNR. So the received signal is then decoded using the turbo decoder. So this is the overall block diagram of turbo decoder where we have two soft input, soft output decoders, one interleaver and one de-interleaver. The turbo decoder, it consists of two CISO decoders where these decoders exchange extrinsic information to interleaving and de-interleaving. The decoder performs multiple iterations, and with every iteration, the decoding accuracy improves. Finally, the soft values are converted into binary values to recover the original transmitted data. Now let us briefly look at the mathematical analysis behind turbo decoding. This slide presents the mathematical basis of turbo decoding. The first equation, log likelihood ratio. It estimates the LLR estimates the probability of whether the received bit is 0 or 1. It says whether the values which we have received is whether it is 1 or 0. A higher LLR indicates higher confidence in the decoded bit. The second equation, it represents the max log map approximation. Instead of performing complex logarithm calculations, it approximates the computation using the maximum function, where it reduces computational complexity and also hardware requirements, making it suitable for FPGA implementation. Although there is a slight reduction in BER performance, it significantly it improves hardware efficiency also. Now let us look at the comparative analysis. This slide presents the comparative analysis based on the literature reviewed in the paper. So, I have a graphs for them. Um, so, here the first graph, it compares the bit error rate or BER of different decoding techniques. As the signal to noise ratio increases, BER decreases for all decoding techniques. According to the reviewed studies, MAP provides the lowest BER, as we can see in the graph, while max log map shows a slight increase in BER because of its approximation. Thus, the second graph, it compares the throughput comparison. It shows that parallel map provides the highest throughput because multiple decoding operations are performed simultaneously. So, max log map also provides good throughput while maintaining power computational complexity. So, this comparison highlights the trade-offs between decoding accuracy and processing speed. So, now let us look at the hardware complexity. The graph compares FPGA resource utilization in terms of lookup tables. According to literature, max log map requires the least FPGA resource because of its simplified computation. Map and we can see in the graph here, map and parallel map, they require more hardware resources due to their complex decoding operations. Here, machine learning based decoding requires the highest hardware resources because of model storage and computation. Therefore, the max log map is considered more suitable for FPGA implementation when hardware efficiency is important. Based on these observations, the key findings and research gaps are as follows. From the reviewed literature, we observed that no single decoding algorithm satisfies all performance requirements. MAP provides the best bit error ratio performance. Max log map is friendly, FPGA friendly because of its lower hardware complexity. Machine learning based techniques improve adaptability under different channel conditions. And however, existing techniques, they mainly focus either on improving decoding performance or reducing implementation complexity. Therefore, there is a still need of efficient hybrid FPGA-based adaptive turbo decoders, which that can balance both performance and hardware efficiency. So, these observations lead us to the following future research directions. Future work, it focuses on developing hybrid log map and machine learning assisted turbo decoding techniques. Other research directions include FPGA optimization, adaptive decoding based on channel conditions, high throughput decoder architectures, and AI assisted turbo decoding for future 5G and 6G communication systems. Finally, let me conclude my presentation. In conclusion, turbo cores, they remain on the most effective error correction techniques for reliable communication systems. Among the reviewed techniques, MaxLogMap provides a good balance between decoding performance and FPGA implementation complexity. Machine learning based approaches are promising, but they require future further optimizations for practical hardware implementation. This concludes my presentation. Thank you for your kind attention. I would be happy to answer the questions.
Yes, thank you so much. I have one question with you. What is the
Yes,
key
ma'am.
research contribution or the novelty of this paper?
Pardon, ma'am.
What is the key research contribution or novelty of this paper?
Um, like the novelty of the review paper, it lies in providing a comprehensive comparison of turbo encoder and decoder techniques, ma'am. It is by considering the multiple performance parameters simultaneously, like including bit error rate, throughput, hardware complexity, latency, and also
Oh,
FPGA suitability, ma'am.
okay.
Unlike there are many previously reviews that focus only on two aspects. Like our paper brings three parameters together in single comparative study. And here in our paper, we also discussed about the recent machine learning based decoding techniques where it identified the research gaps for developing efficient hybrid FPGA based decoders, ma'am.
Okay. So how can this work will be extended to improve the turbo decoder performance?
Like we can use ML based assisted decoders. Like we can use ML machine learning, ma'am,
Okay.
to improve
Okay.
this.
Okay. Thank you so much.
Thank you, ma'am.
Okay, thank you, Anusha, for your presentation.
Thank you, ma'am.
Yes, so our next speaker is Heli Martinez Alvarez. Heli, are you present in the meeting? Or any of her co-authors is present on behalf of her? Okay, let me check once. Okay, I think we should move on with the next presentation. So next we have Ankur Chopde. Ankur, are you present?
Yes, ma'am.
Yes, so he is going to speak on his work titled as Confidence Aware AI Based Adaptive Filtering for IoT Sensor Signals. So, Ankur, are you ready?
Yes, ma'am.
Yes, you can start sharing the screen.
Is my screen visible, ma'am?
Yes, it is visible.
So let's start with my paper title Confidence Aware AI Based Adaptive Filtering for IoT Sensor and Signal. This paper is co-authored by Parth Aglave, Sai Prasad Kautte and guided by Professor Archana Ratnaparki and Professor Sagar Janokar. We are from Department of Electronics and Telecommunication of Vishwakarma Institute of Technology. So this is a 1D CNN model which goes beyond the some previous work and which calculates the confidence, and also it increases the SNR ratio as per compared to LMS and NLMS. As it is TF Lite model, it can be implemented on the edge devices. So first, abstract. So simple, the IoT sensors are often corrupted by various noises like linear, non-linear, non-stationary or stationary. So there are some traditional filters like LMS, NLMS are well, those perform well, but under some conditions. But when there are dynamic conditions or messy conditions, these filters can break down. So we propose a confidence aware AI adaptive filtering framework which uses a 1D CNN. It has two outputs, one is signal regression and other one is confidence. So this model performs a simultaneous signal denoising, and also it calculates the confidence, how much reliable that output is. So these are the some points we are going to cover in the presentation. So let's start with the introduction. So in real world, the IoT systems may rely on the sensor to capture the real world data. So the data can be humidity, temperature, pressure, but due to some noise in the environment, this data can be corrupted, making those signals noisy or corrupted signals which can give wrong decisions at output. So these noises, as I said, these noises can be linear, non-linear. So in order to avoid these, the distorted signals are going through a specific model which we have designed. So this is some literature survey we did from some papers. The LMS and NLMS, these type of filters are low computational and these are also cheap, but this can't perform very well on non-linear or non-stationary noise. The probabilistic LMS, also called as PLMS, this improves the LMS and NLMS filter, but it treats the unknown noise as a random variable instead of a fixed constant. Then there are various kernel based filters, but those filters are not applicable or best for the edge devices which have some resources limitations. Then these there are other also 1D CNN, but these give only the output as a denoised signal. So from that, by considering all the limitations of edge devices and the research gap as existing researches approaches it suppresses the noise, but it rarely estimates the confidence. So we created a model which can denoise as well as estimate the confidence in order to how much we can trust on that output. So there are some objectives. So the of this paper is to develop a model which can be applicable for any type of edge devices, designing a very reliable and low resource consumption model which can be implemented on various small devices or microcontrollers, which uses a MSC and SNR, in which in MSC the square difference between the calculated and actual error, which is from which the confidence is calculated. So first one is the methodology. So at first the signal is generated. The signal can be sinusoidal or square wave or any other wave. Then there is a noise addition. In order to make that signal corrupted, we add some Gaussian or other type of noise. So after that, this signal is gone through 256 sampling sliding, in which the signal is break into 256 data points, and after that in 1D CNN extraction, here the changes from that waveform are noted, and then the dual output head reconstructs the signal as a clean wave, and also it estimates the reliability confidence of that output. So here is the one sample graph generated from that model. Then the model architecture. This is a dual output design. As I said, one reconstructs the clean signal and other calculates the confidence. So in which we used Adam optimizer in order to get that stable output, and MSC regression in order to get proper calculated confidence estimation, and binary cross entropy to calculate the difference between the actual and predicted output. This model is exported as keras.h5 and TensorFlow both, so it can be applied on high-end also as well as low-end devices. Then there is a first result, sinusoidal and linear sine mix. So here the LMS reduces noise, but it introduces some non-linearity. Same for NLMS, but as for the model output, it accurate with some accuracy. It can reconstruct the signal and follow the same as denoised signal. And also here the another advantage is it increases the SNR by 10 or 15 to 16 dB from traditional LMS and NLMS. This is the second signal, which is square wave. Square wave. So in this case, the model is not perfectly accurate. So for this, the confidence estimation is also low. Then there is a AM interference. This model is mostly suitable for non-linears. As you can see, this is a non-linear signal with some spikes as noise. So the model can denoise the signal perfectly by also increasing the SNR up to 15 to 16 decibels. Then this is some SNR improvement summary. So as first we see in sinusoidal, the SNR increased was up to 10 decibels, and in AM interference or nonlinear, it is increased up to 16 decibels. So it is giving more accurate output for nonlinear signals. Then, so let's move it to the conclusion. So this is a framework which was successfully developed for IoT sensors, which can be implemented on edge devices or sensor if there is a small microcontroller. Then this 1D CNN model, it exactly handles the nonlinear or non-stationary types of signal. It is a step forward than LMS and NLMS by improving the output reliability, and it can also increase the signal to noise ratio. After that, so in this model, the future scope is, after that the model can be applied on edge devices in order to check the real world output of this model, so we can get the real world validation. After that, the online adoption, and also by making this model more efficient as it is currently is. So these are the some references we these are the some best references we got for this project. So thank you.
Yes, thank you so much. So my question is,
Yes, ma'am.
how does the confidence estimation module improve the robustness and reliability of the signal?
So as the model gives the reconstructed signal, the confidence estimates the confidence value by MSE, like the mean square technique, which calculates the error square difference between error square and its average is given as its average and binary entropy, which denotes the 0 to 1 between the error, like the calculated probabilistic output and real output. So from both of these, the confidence is estimated, and upon which it is decided whether we use the output of signal or not.
Okay. Okay. Thank you.
Thank you, ma'am.
Okay. Thank you, Ankur, for your presentation. You can stop sharing your screen. Yes, so our next presenter is Arghya Kamal Roy. Arghya, are you present in the meeting?
Yes, ma'am.
Yes. So he is here to present his work titled as Design and Development of an Immersive Virtual Reality System for Enhancing Learning Outcomes in Physiology Education. So yes, you can start sharing, Arghya.
Ma'am, I hope my screen is visible now.
Yes, it is visible.
Uh, Good afternoon, respected chairperson and my fellow presenter. Myself, Arghya Kamalbhai. I am presenting my paper on behalf of also Renide and Dr. Abhishek Kumar. They are the co-author. My paper topic was Design and Development of an Immersive Virtual Reality System for enhanced learning outcome in physiology educations. So, in physiology education, especially in PU level, students struggle to understand what is happening inside the human body. And human body are very complex. So, it's very difficult to understand without seeing it or without interacting it with them, what is actually happening it. So VR anime is a term which refers to virtual reality and 3D animations. With the help of VR anime, we can create the 3D environment or the virtual human body or human organs. Student can easily see it, what is happening inside the human body. Even a student can interact with them, which can leading to better understanding and better result and better retentions for longer runs. So in this research, we're trying to find out two questions like what is the difference we are getting from traditional learning versus like virtual reality aided learning. And second question, we're trying to looking for what is student perception for this such new technology like this immersive technology as a VR. What is student are accepting this technology or what is their perception about this technology? So this application has been developed by us. It has been developed in three sections. Like first section is about a basic operation theater environment, and in that, student or the audience can cut the human body and see what is happening inside the human body, and there is a organ like human heart, how it's functioning inside that. So these steps has been done through the concept art, like how player is performing, where the interaction will start and how it will getting to end. And based on this planning, this complete environment has been done 3D model through Autodesk Maya, and complete 3D model has been textured through the Subsys Painter. And after that, VR has been integrated through the Unreal Engine by using of visual language such as Blueprint. So now this is the storyboard. So how player is interacting from one step to other steps. So this is everything has been pre-planned through the sketches. And once the sketch is done, we have taken some real life images, like such as this as oxygen mask as an example. We have created the 3D model sheet, and based on this model sheet, 3D model has been done in this frame. You can see it. And the right side, it's called texture unwrapping, where all the image or all the model has been unwrapped, and in the down, all the textures which has been applying here in the right side as a final mask or final any model, how it's going to look. So here is a pre-visualization of the human heart. This is a human heart from outside, left ventricle and right ventricles in a 3D model. This is an X-ray view. We can see inside and outside both. And this is the environment has been designed as a concept art. After that, those are the character, and this is the final cut with the spatula. This is the drill for the bigger cut and spreader for increasing the cuts. And this is the blade shape where has been arranged here. So if we have interacted with any part, we can go to the next part. So all the blade shape of the model has been replaced as a chase model. So this is the blueprint what we have used for creating this interaction, and there all at the trigger box. If a spatula or drill has been interacting with the trigger box with this trigger box, so next plane shape will come and it will take place or alter the models. So I have the video, but because of time consume, I will not play the whole video. I'll just go quick forward how the application will uh, interact or how player can see it or how player can feel it. So like that player can come open interact with any object, they can pick it, grab it, and they can go closer to any character. There will be indicator from the light as well as slider, and from this display also it will show what to do, how to do, what to next to do. Thing has been once they done, they can place the one gadget, they can pick another gadget, they can cut it off, and once they have cut it off, they can take the slider, they can come back and they can place it. At the moment it's getting bigger cut, they can see the heart sounds and all, so they can go closer the human heart. Even wherever they will overlap their trigger, they can see the name of these organs. Even they can see inside also what is happening and how the blood will come and what side blood will go. So like this, everything has been designed in this application. Once this is done, they can restart also, they can play it one more. So the total number of student was 120. Bangalore-based PU University was a targeted audience, and it has been done in a three-part: pre-test, post-test, and delayed post-test. So for it was like around 35 MCQ-based question. It's asked for control group and experimental group, both the teams, and only experimental group was asked three Likert scale-based question about their experience and their perception about these technologies. So you can see here we have the result for U test. This left side is control group and right side is the experimental group. So right side, after applying the VR technology, a student is getting more engaging or more retention they have. So they are performing better in the MCQ answer questions. And even fireman's ANOVA result, we have to see fireman's ANOVA, and we'll Wilcoxon as well as so Fireman ANOVA result chi-square value was 89.43, which p-value is less than 0.001. So which is highly significant, and this VR scored significant over the time, like it's a post-test, they are still retaining it. Even the Wilcoxon test, the W value, the Z value, we got it 6 to 6, and the P value was 0.033. So VR score confirmed the durable retentions also. So this is a post-test result. Wilcoxon is giving the significant in the post-test result. So there is the feedback questions based on of what is student engagement, understanding, application, critical thinking, and retentions. And the mean value was we got is above 3.8 or around 3.8. It's a good distributions. And also the Spearman correlations value, the rho value we got close to zero, but p value we get greater than 0.05, so which is not statistically significant. So if we talk about final conclusion in the discussion, we have seen that who students has been and use VR as a education aided tool, they are performing better, even this remembering for long time. But VR is not so accessible tool. So although we have tested this in a technical city like Bengaluru, so student maybe are more technical confident, so they are very good confident with the applications or the VR technologies. But we have unfortunately we are unable to test it with the rural area, so we can't tell that what in that perspective in the rural area, what is the student perception or how students performing. And another limitation we have faced that we have created only for one applications or one topic. We can choose different multiple streams or the multiple subject, then we can get the another better result, like how actually is this applicable for all the subject or all the topic or not. So this was from my side, and thank you.
Yes, thank you so much. So my question is, how did you evaluate the effectiveness of the VR-based learning environment, and why was the Man Whitney U test selected for the statistical analysis?
Ma'am, first thing, we have done the pre-test ones, who pre-test and post-test dedicatedly. We have not chosen that who will be go for experimental group and the control group. So we have normally chosen and we have give them pre-test and post-test one set of group, like control group. They are simply how we teach in classroom. So this is the topic we can the blackboard sketching and all. We have explained about that about the topic. Another topic we have about the blackboard, like about the talking in the class, we have given them VR system so they can also learn or explain the same things what we are talking in the orally. So like this, we have done it. And we have used like Christ University student as well as Jain University PU students for that.
Okay. And what is the research novelty of integrating the ICT and virtual reality for teaching?
Ma'am, as of now, how much we have seen in that database, like majority of this type of test has been done with the medical scientists or the medical expertise. But who are the NPO student? They are the only thing. They are this is a very key area, like where they are going to which area, like they are going to science or medicals or engineering. If they are getting a little bit clear idea about the physiology, so maybe that could be beneficial for choosing their career path. So this is a novelty, like we are targeting the PU university, which is more negligible area in such topic.
Okay, thank you so much.
Thank you.
Okay, so for our next presentation, we have Ravi Shirisha. Ravi, are you present in the lecture? Okay, let me check one.
Ma'am, I'm here, ma'am. Sorry. Sorry for
Yes,
the late.
Ravi is.
Yeah.
Yes. She is going to speak on digital retail for sustainability, a systematic literature review of consumer behavior, platform persuasion, and last mile trade-offs. So yes, ma'am, you can start sharing your screen.
Yeah, 1 year. Is my screen visible?
No, actually the screen is shared, but the presentation is not visible. So what you can do is when you click on share, you have to click the presentation window and not the entire screen.
1 minute, ma'am.
Yes.
Yeah, shit. 1 minute.
Okay, so
1 minute,
uh,
ma'am. 1 minute, ma'am.
so you can resolve the issue and we can come back to you after the
No,
next present.
no. Is it visible now?
Yes,
Sorry for that.
that's
Okay.
fine.
Good afternoon, everyone. Today I'm presenting on Digital Retail for Sustainability, a systematic literature review of consumer behavior, platform persuasion, and last mile trade-offs. So this paper was done with my a guide, Dr. Payal Das. We both worked on this, and we are from Amrita Vishwavidyapeetham. So this is the flow of my presentation. I'll just introduce and the research questions. Later comes the Prisma model, how we have done the Prisma model and the bibliometric approach. Next, what are the thematic clusters we have got and the clusters? I'll explain the clusters. And next, I'll explain about the class cluster paradox. Next comes the theoretical, practical, and policy implications. Then finally goes with the limitations and future research direction. So when it comes to research problem, our topic was about retail because I was concentrating on retailing. I just wanted to learn the role of retailing in sustainability. So when we have started the research, we have in our mind the research problem was the rapidly expanding consumption infrastructure. You know these days like how the consumption levels have been increased worldwide. No, it's not only problem locally, but it is a worldwide problem. And how the sustainable development has been related to all this consumption power of the customers. Next, we have two competing narratives. The platforms can promote sustain. Of course, many are. We are talking about sustainability, but how much in reality is it having effect? That is what we want to test. And the literature, what was done, like the previous studies, what was done on this thing, and it looks very fragmented and it doesn't have a link between one another. So we thought this would be a wonderful research problem to interrogate. So the research questions goes this way. We try to find out the dominant thematic clusters, and next how platforms shape sustainable behavior, and next comes sustainability convenience paradox in the last mile delivery, and cross cluster paradox under and underserved SDGs. So this is the Prisma diagram that we have followed. This is the Prisma process screening we have done. Generally, we have identified from the Scoopers, we have identified around 2,234 papers, articles using the search string which you can see in the table. It combines digital marketing, retailing, AI, and sustainability. So using this string, we have found out around 2,234, and which the study was a lifespan of 10 years. And then from that, we have screened them using the subject area, document type, and language. And then next comes the 234, which we have picked. These articles are from the top tier of Scoopers, like 90 plus percentile. These articles have been selected for the study to maintain the quality of the study. So, when we have given bibliometrics as our data analysis tool, and when we have given all this data to the bibliometrics, we have finally got three main clusters. So the first cluster was platform and persuasion. The second cluster is operational trade-offs, and the third cluster is supply chain and marketplace. So these are the three main clusters which are addressing all our research questions. The cluster itself is addressing the research question 1. The cluster 1 generally addresses the research question 2, and this cluster 2 addresses our research question 3, and the 3 addresses our 4. So when you can see here how the cluster is synthesized and how top cited papers from this cluster, from this area, and what was the SDG link. This table tells you what exactly is the literature that has been done under these clusters. So this is all about the cluster 1. Here, cluster 1 is about platform persuasion, and sustainable adoption. Digital platform influence sustainable consumer behavior through persuasion, personalization, and interface. Of course, we try to tell customers to use sustainable goods, and we put our efforts to for them to advertise through sustainability. But the problem is here exists with the background work that we are doing. When we are targeting customers, the transparency has to be maintained. So this is the main problem with this cluster. And the studies, the most cited papers under this study always find the same findings. Digital platforms enable collaborative, sustainable consumption. The second paper says it links platform efficiency to sustainable behavior, highlights the role of social influence. Sustainability is moderated by price and convenience. So emphasis blockchain enabled transparency. See, this is the main gap that we have found. You're working on the front end of the customer to promote the sustainability, but at the background, when you're really working, it's not being applied. That's the main problem we have answered here. So the third research question is answered by cluster number 2, the sustainable consumption and last mile retail operations. This cluster examines the last mile delivery, packing, environmental impact, and purchasing trade-offs. Sustainability here is a matter of operational design, not just customer attitudes. As I told you earlier, it's not about the customer purchase. It is all about the it is not only about the sales, it is all about the manufacturing process or the process of delivering the goods to the final customer. So these are the most highly cited papers from the literature they have found according to this cluster. Generally, the main findings are: identifies last mile delivery as a sustainable bottleneck, highlights the impact of e-commerce packaging, convenience dominates sustainable delivery choices, demonstrates the intention behavior gap, shows alternative emission reducing delivery models. So the next cluster is strategic supply chain and marketplace optimization. So apart from RQ2 and 3, RQ4 is directly related to the system that we are working in. So the cluster examines how supply chain design and marketplace structure shape sustainable. Even the governance comes in this area, because even it has a very huge effect on how to promote sustainability. So these are the most top cited papers from this cluster that we have found. Platform strategies shape economic and environmental outcomes, links digitalization to supply chain efficiency, explains profitability, sustainability, investment trade-offs, and stresses resilience for digital retail adoption. Emphasizes smart logistics enhancing efficiency, which can reduce the waste that is created in a supply chain also. So these are the main clusters. So among these 3 clusters, we have built up we have found 4 paradoxes that is presented here using an image. The first paradox is sustainable versus convenience. Are really customers going for sustainability, or they're looking for convenience? So, for example, eco-labeled and AI recommendations versus speedy delivery, cost, and ease of use. Are they really looking? Because the cost is a main problem here. So convenience is playing an important role when it comes to sustainability. So this is covering SDG 12 and the persuasion versus customer autonomy. So we are personalizing their apps and everything, but what about the privacy? The privacy concern is being raised where SDG 9 has been proposed. And green interface versus fulfillment reality, where sustainability messaging versus delivery packaging and in return impact. So here covers the SDG 12 and 11, where we are talking about sustainability, but what really works there on ground is very important. So the fulfillment reality is not much looked into. The last paradox is consumer agency versus system constraints. So individual choices emphasized is structurally limited to supply chain and platform governance. Here you can see that SDG 9 and 12 are being covered. These are the 4 paradoxes that we have proposed in the paper coming out of the 3 clusters. So theoretical implications: digital retail is conceptualized as a complex multi-layered system where outcomes emerge from the interaction of platform design, fulfillment operations, or system-level governance rather than any single domain in isolation. Behavioral, technological, and operational perspectives are shown as are to be independent, not separable. So because the main theoretical influence, everything is fragmented when we talk about the literature in this area. So everything is interlinked. One cannot work without another. So this is called as green interface and gray infrastructure paradox. Exposes the limit of a single theory expansions and motivates integrative and multi-level frameworks. This system view advances SDG 12 by reframing responsible consumption as a property of the whole retail system, not just the customer touch point. So what are the practical implications that we propose? The front end of sustainable messaging is inadequate unless back end delivery, packaging, and returns processes are aligned with. Embed environmentally friendly defaults into our checkout and delivery flows. Maintain transparency in personalization so recommendation logic does not erode customer trust. Minimize logistic frictions and pushes customers back toward convenience first choice. Aligning front end and back end practice advances using SDG 12, responsible consumption, and SDG 11, which is sustainable delivery in urban systems. Policy implications. Policy must have moved beyond customer facing measures to system level regulation, because this talks policy implications and it has to start with the net zero supply chain frameworks rather than asking the customers to use the sustainable products at their end. Instead, we have to refine the whole system. So this is the point about policy implications. The limitations and the future research directions are here. So the limitations are relies on, generally we have relied only on one database that can limit our review, and we have selected top tier in keeping in mind to increase the quality of the paper. But I think when we concentrated on such things, maybe we have missed some important papers that must have not been covered. So bibliometric paper uses author keywords and abstracts. So mainly abstracts and authors are used for the refinement. So maybe some conceptual themes or dominant themes must have been missed. Citation-based ranking may underrepresent some most recent studies because citations increase only over years. So we must have missed some of the recent papers because citations were taken into consideration. The 10 years window may already lag the phase of, because if we are talking about AI, maybe we have taken too much of 10 years of, because we just wanted to learn how it has from digital to AI, how it has been transformed. So this is the limitation we have. In the future research direction, expand databases beyond Scopus. As I told you, we can study on the future. We can use Web of Science or Scopus and many other databases all together to get a good number of literature we can do. Adopt longitudinal designs to track the intention and behavior gap over time, and empirically test so there is not empirically tested. So it is a future. This leads to direction. Next comes is AI and next generative AI. How personalization reshapes the green nudging at the scale. This is the end of and this is the conclusion part. The central products of the whole learning is the platforms advocate sustainability at the interface while operation systems undermine it, producing a green interface gray infrastructure gap. So this is my closing statement. Closing this gap requires alignment across three layers, like platform, fulfillment, and the system. So this is the end of the presentation. Thank you.
Yes, thank you so much. So my question is, how does digital retail influence sustainable consumer behavior are used?
Ma'am, can you please repeat?
How does this digital retail influence sustainable consumer behavior will take?
So when we go for digital retailing, ma'am, we are increasing because earlier the packaging was very less, but when it comes to digitality or e-commerce retailing, the usage of this material has been increased. So this is the main influence that digital marketing is doing. So how we are helping our customers to select the items that use less plastic or less packaging. That is the main thing that influences, ma'am.
Okay. So what is the main research gap addressed in this study?
The main discussion, the main study is fragmented, ma'am, because see, we are talking only about the end product, like end product selling. But what about the system behind, the logistics, the manufacturing? Everything is not interrelated among the study. So this is the main research gap that we have found, and we are working on it, ma'am, for our research in the future.
Okay.
Okay. Thank you, ma'am.
Thank you.
Thank you.
Okay, thank you so much, Sirisha ma'am, for your presentation. So, up next we have Shashank Channawar. Shashank, are you present?
Yes, I am present.
Yes. So, he is going to speak on his paper titled as Enhancing Rail Madad with AI-powered complaint management. So, Shashank, you can start sharing.
Yes, ma'am. Better question. Yes, is my screen visible?
Yes. Yes, it is visible. You can start.
Yeah, my good afternoon, everyone. Myself, Shashank. My paper enhancing rail method through AI-powered complaint management system. So I'm the co-author for this. I have with my Kavita ma'am Patil as my college guide for this from the Department of Computer Science and Business System from JSPM Pune. So, good afternoon. Our research paper, like Indian Railways, receive a large number of passenger complaint every day. So, existing system rely on a manual processing, causing delays and inefficient prioritization. So, our objective was to build an AI-driven system that automates complaint analysis and routing. So, the challenges include manual complaint classification, delayed grievance solution, and lack of intelligent systems. So, we developed so our goal was to overcome this issue using artificial intelligence and natural language processing (NLP). So, proposed solution: we develop a full stack solution consistent of a React frontend, Node.js backend, and MongoDB database, and a Python Flux machine learning server. So the system automatically predict complaint category, sentiment, as well as priority with the help of severity. So I will go through the technical workflow for my project. First of all, the passenger submit a complaint through our React frontend that we have developed. Yes. So after he or she submit the complaint, the React frontend send the data to Node.js backend via REST API. So backend validate and forward complaint to the ML Flux server that we have fine-tuned for our project. So NLP pre-process perform and generate the embedding. So after the generation of embedding, we perform the sentiment analysis on the basis of the complaint we received. We judge them on the basis of positive, neutral, and negative. So after the classification of the complaint, the model predicts the complaint category. It has several categories such as waste management, and emergency service, etc. So after the classification, we divide into the category such as sentiment, and we use keyword rules that determine the priority and the severity of the complaint that we received on the Rail Mother platform.
Shashank, your slide is not changed.
Okay, sorry.
Just change your slides.
Yes, is it visible now?
Yes, now visible.
Yeah. For the technology stack, I have used front end, Tailwind CSS. We have used backend. In the backend, we use Node.js and Express.js. We use database as MongoDB and machine learning. We use Python for this as well as Hugging Face and the REST API. So the result was the average processing time was approximately 4 seconds, and after our classification and research, after the pre-processing, we can achieve a 91.25 classification accuracy during our evaluation. So the dashboard enables efficient monitoring and prioritization. So the automated complaint categorization, line sentiment analysis, priority prediction, AI chatbot, and real-time dashboard help us to solve the issue. So about the future outcome, so we can have a multilingual support, and we can have OCR based image analysis. We can have voice complaint registration and large scale deployment. So the conclusion for this, like the proposed system demonstrate and how we can integrate AI and NLP to modernize the railway grievance system by reducing the manual effort, like we can by improving the prioritization and enabling faster complaint resolution. So I'm sharing my experimental result. We got a random forest accuracy of 91.25%, and we have a bud classifier of 90.40. The rest is visible in this game. About the performance highlight, the average processing time was very less. After that, we can have a real-time complaint categorization. Like we also automate priority detection. So, thank you.
Yes, done with the presentation.
Yes, ma'am. I'm done with it.
Okay. So what AI techniques are used to improve the rail-made complaint management system?
Yeah, we use an NLP, Natural Language Processing Model. So, like
Okay.
for yes, that help us to recognize which complaint we received from them. Like we have it perform tokenization, text pre-processing, context understanding, and feature extraction using transformer embedding. And we also use distill BERT model. That is a lightweight transformer model from Hugging Face that is used for sentiment analysis. Like that help us to determine if complaint is positive, neutral, or negative. Yeah.
How does the proposed AI-based system improve the complaint resolution efficiency to the
Yeah.
existing system? How it will compare?
Yeah, like, first of all, the railway use their manual. The railway current railway mother system manually allows passenger to submit complaint online. So complaints are reviewed and categorized manually. So that takes a huge amount of time to look at and solve the complaint. So there is no automatic sentiment analysis system. So we develop a automatic complaint classification. So AI instantly categorize complaint on the basis of food, delay, safety, and cleanliness. They are the categories of the complaint we receive. So after the sentiment analysis and priority severity prediction, the complaint gets resolved fastly within seconds. Thank you.
Yes, thank you.
Okay, so our next speaker is Shubham Agrahari. Shubham, are you ready?
Yes, ma'am.
Yes. So his paper is titled as Predicting Brain Tumor Presence and Type with Deep Neural Networks, a machine learning based strategy of early medical diagnosis. So Shubham, you can start sharing your screen.
Okay. So, thank you. Is my screen visible?
Yes, it is visible.
Okay. So, good afternoon, dear judges and panel members. So, my name is Shubham Agrari, and I'm a college student of ABS Engineering College, along with my co-authors, Mr. Sanskar Gupta, Yash Kumar Singh, and Uday. So, this project is under the guidance of Mr. Deepak Neja. So, I'm going to present my paper predicting brain tumor presence and type with deep learning. So here is project. This project present a deep learning based on the systematic automatic detection classification brain tumor through MRI images. It uses a convolutional exception model which helps to identify the brain tumors. The system integrates the image processing, transfer learning, and data augmentation to achieve classification accuracy and predictions. So currently, MRI scans analyzed manually by radiologists, which is a time-consuming and it depends on expert knowledge. Our research focuses on using deep learning to automatically detect and classify brain tumors from MRI images. So the problem statement is brain tumor are, as we know that the brain tumor is a very concerned disease. So we have to understand what brain tumors affect and so brain tumor are life-threatening conditions and timely diagnosis is crucial for effective treatment. However, manual analysis and MRI scans is timely consuming, subjective and difficult to scale. With the increased number of patients leading with delays or inconsistent diagnosis decisions. So the objective of project is to detect brain tumors. It classifies the brain tumor into 4 categories. The first category is glaucoma, meningia, second is meningia, third is pituitary, and fourth is no tumor. So let us understand what is glaucoma. So the glioma brain tumor is from the brain cells, with brain supporting cells, and the meninges is brain protective cells, and pituitary tumor is from the pituitary glands. So how it's working, our project, how it's works. So first we have developed a model, so in which we upload a simple MRI images which was pre-processed, and then resize normalize. After that the classify after that MRI images classify into glaucoma, meninges, and pituitary tumors. So what are the requirements? Functional requirements are MRI images, pre-processing, and brain tumor classification, system automation, data handling. Requirement of project. Requirement of project. So it's contains hardware requirement and software requirements. So development machine, minimum 8 GB RAMs, and software requirements are Pythons, and we use libraries TensorFlow, Keras, NumPy, OpenCV, Matplotlib, Skitlearn, etc. Methodology. MRI images collection collect brain tumor images uploaded by the user through a web. How it's working, I am explaining. So users through a web-based interface for analysis. Then after that, image pre-processing. So in image pre-processing, the several filters were used, which reduces the noise and standardize the input, resizing and normalizing images effective model. So tumor classification CNN, I uses a CNN exception model which applies a better result. So why I use a CNN model? Why I use exception model? I use exception model because its accuracy rate is 97%, whereas in ResNet it's 82%. Methodology. Handles MRI images request, manage data flow, connect front end with deep learning models. Deep learning inferences module processed MRI images using trained CNN exception model to generate tumor classification. Result visualization display a predicted tumor type and confidence score through an interactive, user-friendly and interface. Outcome: a scalable real-time brain tumor detection system providing accurate and reliable diagnosis support for medical professions. So here is workflow diagram. First, we user upload the MRI images. Then after pre-processing. So in pre-processing, we use grayscale. So what is grayscale? It's a combination of RGB. It's red value, green value, all the additive value. So it gives a gray value. Then after gray value, it's median filter where noises were removed. Then after that, extraction of segmentation and brain tumor. Then feature extraction, texture based, how the image were and what are the differentials between them. Then after that, the ML testing, the algorithm, then test, then classification, and after that we got results. So workflow, as I explained, the workflow: collect brain MRI images from the dataset, user upload, ensure images obtained from the reliable medical sources, image processing, clean and standardize MRI images, remove noise, irrelevant. So case-wise breakdown. So as I have mentioned that it also differentiate which type of brain tumor is glioma, meningioma, pituitary tumor, and no tumor. 4 categories are in the models. So here is the dashboard of my project, and then our conclusions. So automate brain tumor detection using deep learning and medical image processing. Utilize CNN exception model for the accurate classification and MRI images. Implement effective pre-processing model and inference reliable. Provide a user-friendly system, real-time tumor classification, confidence reporting, supporting medical profession in early and accurate diagnosis of brain tumor. Reduces dependency on manual analysis by offering consistent and diagnostic approach. So what are the future scope of this project? So let's talk about future scope. So real-time MRI processing, implement MRI images analysis for faster diagnostic support. As we know that there is number of queues lines where people were waiting for the MRI. So this model helps in fast and pre-post. Multimodal image support. Extend the system to include CT scans and other medical imaging modulates. So AI-driven tumor segmentation, integrate advanced deep learning models for precise tumor boundary detection. Clinical decision support. Connect the system with hospital information system to assist treatment planning. Enhancement medical datasets. Expand training using larger more diverse MRI images and accuracy. So that's all of my project. Thank you. Hello.
Okay, Ishwari ma'am, do you have
Yes,
any
yes,
questions?
yes. I have question. So why did you choose the deep neural network over the machine learning model for brain tumor prediction?
Ma'am, I use deep learning model because I use a CNN exception model. Firstly, we have applied on RESTnet, so its accuracy is 87%. While exception model, CNN exception model, it's give 97% accuracy. That's why we have used a CNN exception CNN.
Okay. So which
Yes.
evaluation metrics were used to validate the performance of the proposed model?
Ma'am, this actually I used CNN where convolutional neural networks models which helps processing.
Ma'am, can I answer? I am a co-author on
Yes,
this paper.
Yes, please, please.
So, ma'am, we used the confusion matrix and the accuracy. Alongside, where I used the precision to metrics for the metrics.
Okay. Okay, thank you.
Thank you, ma'am.
Okay, thank you, Shubham and team for presenting. So, our next presenter is Sarang Sunil Khakal. Uh,
Ma'am,
are
can
you
I
present? Yes, yes, you can, sure.
Thank you.
Sarang, are you present in the meeting? Yes. Is Sarang or any of her co-authors is present in the meeting? Okay, I think no one is responding. She's present, I think. But let's move on to the next presentation till then. Okay, so next we have Shubhika Dubey. Shubhika, are you there?
Yes, ma'am, I'm present.
Yes, so she is here to present her paper titled as Spatio-Temporal Graph Neural Networks for Hydrological Forecasting, a critical review with baseline establishment on the Narmada River Basin. So, Shubhika, you can share your screen and start.
Is my screen visible, ma'am?
Yes, you can start, Shubhika.
Good afternoon, everyone. My name is Shubhika Dubey, and this is joint work with Ruchika Kataria and Dr. Sanjay Agal from Manipal University, Jaipur, and Parel University, Vadodara. Our paper is on spatio-temporal graph neural networks for hydrological forecasting, specifically a critical review of the field combined with the first baseline results on India's Narmada River basin. Let's start with the core problem. Rivers are not a collection of independent points, they are networks. Every downstream gauge station aggregates rainfall, tributary inflow, and reservoir storage from everything upstream of it. That's a structural fact about how rivers work. But most forecasting models, LSTMs, GRUs, don't treat it that way. They treat spatial information as just another input feature, not as a real structure constraint. They can't tell the difference between a station that's casually upstream and one that's just nearby on a map. Spatio-temporal graph neural network or STGNNs are built to fix exactly this. They encode topology and time together, and as we will show, they had never been tested on South Asian monsoon basin before this work. So why the Narmada? Three reasons. First, scale monsoon dominance. It's a 98,796 square kilometer basin draining to the Arabian Sea, and over 90% of its precipitation arrives during the Indian summer monsoon. That creates extreme wet to dry discharge ratios and fast moving flood waves, far more extreme than the Colorado Delaware basins that prior STGN studies focused on. Second, it's heavily regulated. Bargi to Sardar Sarovar, major reservoirs that introduce man-made, non-stationary discharge signals that breaks the stationarity assumptions a lot of these models are quietly built on. Quickly, the conceptual progression. An LSTM or GRU learns each station's time series in isolation. It simply cannot distinguish a casual upstream neighbor from one that's merely geographically close. A graph convolutional network fixes the spatial half. Nodes aggregate information from their topological neighbors through the message passing. An STGNN couples both spatial aggregation plus a temporal model, whether that's an LSTM or, as we use here, multi-head self-attention. Two matrices will come up repeatedly for the rest of this talk, that is NSE, the Nash-Cutcliffe efficiency, where 1 is perfect and above 0.75 is considered good, and KG, the Kling-Gupta efficiency, which decomposes skill into correlation, variability, and bias. Good models sit above 0.7. We reviewed 6 recent studies from 2022 to 2025, spanning the Colorado, the Upper Colorado twice, the Hanjiang in China, the Delaware, and 4 Chinese basins. Different architectures, physics-guided GNNs, GCN LSTM hybrids, adaptive graphs, dynamic multi-channel transformer, physics-embedded heterogeneous networks. The details vary, but the signal is consistent. Every single one of these studies shows STGNNs outperforming sequence-only baselines, with KG and NSC values ranging from the 0.7s up to 0.97. Our contribution sits at the bottom of this table. The Narmada India using hybrid SDG transformer combining GCN with multi-head attention, achieving NSE and R square of 0.8 at the network level. This is, to our knowledge, the first SDGN applied to a South Asian monsoon-driven regulated basin. Stepping back from the individual studies, 4 patterns emerged across the literature. 1, spatial modeling simply wins. Every direct comparison favors SDGNs over LSTM or GRU baselines. 2, graph complexity sets a ceiling, static topology, then auxiliary feature, then adaptive graphs, then dynamic multi-channel graphs, then physics-embedded graphs. Each step up raises both performance and computational cost. 3, attention is becoming the default temporal mechanism. 3 of the 6 methods we reviewed use attention instead of recurrence. So here's our framework in brief. We used hourly data from 7 gauging stations along the actual Narmada flow path from Narmadapuram to Sohagpur, with 3 features per node: rainfall, discharge, and water level. The graph is directed. The graph is a directed graph along the real flow path with adaptive edge weighing layered on top, so the model can discover functional dependencies beyond the direct physical path. Architecturally, it's 2 spatio-temporal blocks: GCN for the spatial step, followed by multi-head self-attention for the temporal step. 4 heads, 64-dimensional embeddings with residual connections and layer norm of training stability. Standard setup otherwise: 70, 15, 15, train validation test split with no leakage, Adam optimizer, learning rate of 10 to the power minus 4, early stopping with a patience of 10. Here are the headline numbers. Our hybrid STG transformer achieves an NSE of 0.8 and R square of 0.8 at the network level. Notice the baselines. The plain LSTM hits 0.95 and GRU hits 0.91. At first glance, ours look weaker. But look at PBIS. Our model shows minus 71.5% versus the LSTM's minus 8.6%. That's a tell. A flat seasonality flowing prediction scores fine when the underlying observed data is corrupted at one station. So we went on So we went looking for exactly where that was happening. Walking the flow path, Narmadapuram to Sohagpur, there's one station, Khaparia, which is the fifth station. And as we can see, 6 of the 7 stations are acceptable to good on NSE and KG. Khaparia is the outlier. And as you just saw, it's a data problem, not a model failure. Our predictions track the true physical signal reasonably well there. They just look terrible against corrupted observed data. Because this is a graph network, that one noisy node propagates outward through the message passing and drags down the whole basin's aggregate error. This is actually a strength of the approach, not a weakness. A plain LSTM would never let us localize the problem this cleanly. The fix is exactly what a companion paper takes on next: station level outlier, detection, robust normalization, adaptive edge weight reduction at Khaparia. The diagnostic points to 3 broader challenges for the field are: the first, data quality is a first order factor. GNNs propagate a single station's flaw across the whole network, and robust training protocols for this are still largely unexplored. Second, monsoon non-stationarity. Interannual variability is rising under climate change, with ENSO and Indian Ocean Dipole indices as candidate future node features. Third, interpretability and trust. Attention weights show which hours mattered. Adaptive graph weights show which stations mattered. And for flood warning operators, that's operationally critical. 4 takeaways to close. STGNNs consistently beat sequence only models because they capture physical dependencies LSTMs and GRUs cannot encode. This is the first ever application of STGNN to a South Asian monsoon driven regulated river basin. NSE and R square of 0.8, establishing working baseline. Our spatial diagnostics pinpointed a single station's data issue that a non-graph model would have simply absorbed as noise. Proving a node-level analysis is essential, not optional. And we have a clear roadmap ahead: data correction, adaptive graph weighing, and flood event evaluation. Thank you, and I'll be happy to take questions.
Yes, yes. Thank you so much. My question is, why did you choose the spatiotemporal graph neural network for hydrological forecasting?
Ma'am, as said in the starting, uh, the uh, the work done previously used LSTMs and GRUs, and they just they put the nodes according to their distance between them, but the GRU placed the nodes according to the sea level.
Okay. So, how was the proposed model validated using the Narmada River Basin dataset?
Um, we validated on 7 hourly discharge gauge along the Narmada mainstream. We took the data set from the Water Commission of India, and through it's the data of around 60 years maybe, and 6 of 7 stations showed solid NSE and KG scores, but one station, Khaperia, had corrupted data, likely a sensor or scaling issue. And because the STGNN passes information across the graph, that single batch station's error propagated to the whole network, dragging down the aggregate score.
Okay. Okay, thank you.
Thank you, ma'am.
Okay, so Shobhika, you can stop sharing your screen. Okay, so we have Atharva Gaikwad. Atharva, are you present?
Excuse me, ma'am.
Yes.
Ma'am, I'm Sarang Kagal. I was having mic issues, so not able to join. But can I share?
Yes, okay. After this presentation, you can present yourself.
Oh, okay, thanks.
Yes. So, Atharva, are you ready?
Yes.
So, he's going to speak on his paper titled as Token Aware Adaptive LoRa and Efficient Fine-Tuning Approach for Large Language Models Using Token Importance. So, Atharva, you can start sharing your screen.
Yes. Am I audible?
Yes, you're audible.
Um, I hope you can see my screen.
Yes, it is visible.
Yes. So, good afternoon, everyone. I'm Atharv Gaikwad. I'm presenting on behalf of my co-authors, and I'm from VIT Pune. Today, I want to talk about something that we ran into while working with LoRa and how that turned into this project, the LoRa. So LoRa is token-aware adaptive LoRa, which is a fine-tuning approach for LLMs using token importance. So here's how it actually started. Most of you probably know about fine-tuned models. So you probably have fine-tuned a model with LoRa at some point. It kind of has become the default. It is efficient, it works well, no complaints. But while we were using it, something kept bugging us. The LoRa, which is a smart layer, it is about where it adapts, which layers, which weights, but it is completely blind about what inside the sentence actually deserves attention. So every single token, whether it is in a sentence, let's say earthquake, or just the, it gets treated exactly the same way during training. So we'll take a sentence like earthquake strikes Japan. So if you're classifying this as a news article, basically two words are doing the work and the rest is just the grammar holding it together. But LoRa doesn't know that. It spends equal effort learning from all of these three words. So we started asking a pretty simple question. The model is already generating signals during training. That tells us how much a token matters. So why are we just throwing that information away? Could we use it to make LoRa a bit more smarter than what it is right now, and without adding any extra supervision or tools? So that is how it led us to Telora. So I'll quickly go through the backgrounds. I guess everyone's familiar with AI. Full fine tuning is very expensive. It is memory, time, compute, and all of it. So that's why PEFT methods exist, and LoRa became popular because it trains only a fraction of parameters by adding small trainable matrices into the layers while freezing the rest of the model. Since then, people have tried to make LoRa even more smarter. People have made Ada LoRa, which figured out how to allocate more parameter budget into layers. QLoRa combined LoRa with quantization, so you could run it on to smaller GPUs. Both were great ideas, but both are still working at the layer or parameter level. No one is really asking whether within a sentence which token deserves more attention. So that is a gap which we went after. So here's the actual idea explained simply before I get into any kind of math. We wanted to find a way automatically how much each token matters without adding any kind of manual labeling. Turns out the answer was already sitting in front of us while we were training.
which was gradients. So if tweaking a token's embedding causes a bit change in the loss, that token clearly matters a lot to what the model is learning right now. So we just take that gradient for each token, measure its size. We use the L2 norm, which is the baseline, and use it as a rough importance score. So it's nice because it's automatic. It comes straight from the model, and it changes as training goes. Since it's based on what the model is currently struggling with, and it is not some fixed property out of the world. Since these raw scores can be all over the place, we normalize them so they can turn into clean weights between 0 and 1 for each sequence. So then we just need to use these weights to scale the loss. So the tokens the model finds important pulls the training harder, and the boring filler words they pull less. So everything stays the same as normal LoRa. The base model is still frozen. We are still only training these small LoRa matrices which we had introduced. We have not added any new parameters. We just changed how the loss is calculated. So which also technically means you could combine this project with already existing systems like Adalora or QLoRa instead of picking one or over the another. So the extra cost is just one additional backward pass per batch to get these gradients. So the solution doesn't change at all. It just kicks in during the training process. So implementation, we built this in PyTorch using Hugging Face transformers and PEFT, all on Google Colab. So we use Tiny Llama as a base model. Nothing fancy here because the goal here was to test whether this idea works or not, and not to chase some leaderboard. LoRa was attached to the attention layers with rank 8, and the scaling factor was 16. We kept identical between our baseline and Telora. So we are testing only the loss function, which we had introduced. And we tested it using AG news dataset, which was working well for us because classifying a news headline usually comes down to only a few couple of keywords, not the whole sentence. So we did. I'll go to the results part. So we ran standard LoRa and Telora side by side, same setup, and what we saw was Telora brought the loss down faster than standard LoRa, especially during the training. So that makes sense. If you're pushing the model to focus on the tokens that actually matter, the limited capacity of the LoRa gets used more. So we also saw a decent bump in accuracy, and the average loss across epochs, which we did, was around 30%. So it was a very significant push to what the base LoRa actually did. So I do want to be honest here. This was just one data set, one small model. So it was a kind of promising early evidence rather than a big claim. So there's a bit of extra training time that comes with the additional backward pass which we introduced. Uh, but the memory and speed, everything remains same other than that. Quickly on how this idea came from, we had actually read three main papers. One was the original LoRa paper, and second was Adalora, and we had derived all our formulas of the weighted Telora from Adalora papers, and we think Telora can sit alongside these methods instead of competing with them. So future scope, I'll say a few things we want to try next. Gradient norms work, but smarter or more context-aware way of scoring tokens uh, could help, especially for long sequences where it could get noisy. And since the overhead is small and inference doesn't change at all, this could work well for edge devices or low resource setups commonly used in IoT. So to wrap it up, Talora is just it's it's not a new architecture. It's a different way to decide what LoRa should actually be. So regular LoRa is smart about where it adapts, but LoRa adds a way to be smart about what it learns from, using the information model is already producing anyways. So thank you, and I'm happy to take any questions.
Yes, thank you so much. So, how the novelty of the proposed token aware adaptive LoRa compared to the standard LoRa fine tuning approach?
Yes. So to answer this question, basically, this is the most important question. The novelty, I'll say, was introducing token level adaptivity. So standard LoRa is parameter efficient because it updates only low rank adapter matrices. Uh, and Talora changes the whole optimization strategy. Instead of assigning equal importance to every token, it computes a gradient based importance score, which I had said was done using L2 norm of the loss gradient, which we had calculated. And these scores are then normalized and used to weight the per token loss. So, as a conclusion, LoRa parameters receive stronger updates to those tokens specifically, which are semantically important, and the weaker updates less from the information tokens, while keeping the parameter count and architecture unchanged.
Okay. Okay, thank you.
Thank you.
Thank you, Atharva, for presenting. So next, Sarang, are you ready? Sarang
Yes,
Khakar?
ma'am. Am I audible now?
Yes, you're audible. You can start sharing your screen.
My PPT is visible.
Yes, you can start.
Okay. So, good afternoon, everyone. I'm Sarang Khakar, presenting from the Department of Instrumentation and Control, COEP Technological University, Pune. Uh, our today's topic is prediction of pneumatic control valve stem position using data-driven model, where we compare two forecasting approaches, ARIMA and LSTM, using real-time data from Delta V, DCS system. Here quickly my roadmap, which I follow during the presentation. So, why valve health matter? Control valve are the final control element in almost every industrial processes. Continuously monitoring them while they run instead of waiting for a shutdown save both time and money. Some numbers to highlight why this matter. Only about 33% of industrial controllers actually run at their intended efficiency. 20 to 30% of control loop variation is caused by fault like stiction and hysteresis. And 90% of industrial control valves are pneumatically operated. So, this is a very widely applicable problem. Why do we want to predict steam position specifically? The answer is shutdown-based maintenance is expensive and does reflect real running conditions. Stiction is a kind of internal friction. It reduces positioning accuracy. So, if we can forecast how the wall stream should move, we can catch deviation early before they affect the whole control loop. Um, Here are the some literature reviews. Has vibration stiction based bearing fault detection, machine learning method for pump cavitation and valve fault, and SCADA based motor control monitoring. Our key study compares ALIMA and LSTM directly and showed LSTM gives better accuracy for time series data, which is strong motivation for my project for comparison to. Here are some research gaps and objectives. The research gaps are most existing works focuses on bringing a fault, pump cavitation, or genetic SCADA monitoring. Very little work predicts the stream position of a pneumatic control valve under real fault conditions using real industrial or DCS data. Now, our objectives are to collect real-time steam position and control signal data via foundation field bus and historian data, to develop and compare ARIMA and LSTM model to forecast the valve steam position. Also, to introduce control faults, air leakage. Control faults are air leakage, one turn and two turn stiction. Let me explain stiction briefly. Since it's the main fault we study as defined by ISS standard SP 75.005. Stiction is the extra resistive a valve must overcome before it starts moving. This graph shows exactly that stiction pattern. The flat dead band, then the sudden jump visible in real valve data. Yes. Here are faults in control valves. Two related faults are hysteresis. Here the valve responds differently for increasing versus decreasing signals, and backlash, a mechanical dead zone caused by looseness between parts. In this work, we focus on stiction, but these two, LSTM and hysteresis and backlash, are planned as future extensions. Now, here is our setup. Use a centrifugal pump, a globe type control valve, a differential pressure transmitter, and an air filter regulator. 40 mm pipeline diameter are the specifications. Control input range of 10 to 90% and 20 psi air supply pressure. This is the physical rig where all our data was collected. So here is the methodology. How delta V DCS integration is done. The valve is connected to the delta V DCS through a foundation field bus interface. We use an analog output block to control valve position. A process history view to measure real-time threads, and a historian database to store the data was tagged. Here are some faults. We deliberately introduce three fault conditions: supply air leakage, one turn stiction, and two turn stiction. In total, we collected 5,339 samples over 89 minutes at 1 hour sampling rate. We split this into 3,577 training samples, about 67%, and 176 testing samples at 33%. The operational band and parameters. The key parameters we focus is what called the operational band. simply the difference between control signal percentage and the actual steam position percentage. This is important because it directly captures the deviation caused by stiction or air leakage. Um, Here are two forecasting paradigms. We compare two approaches head to head, ARIMA and LSTM. ARIMA, a classical statistical model that capture linear patterns, and LSTM, a deep learning model that capture non-linear long-term dependencies. Both are trained on the same operational band data. So the comparison is fair. Uh, So here are some components for the ARIMA: autoregressive, integrated, and moving average. Um, Here is LSTM capturing long-term dependencies. The LSTM network is an advanced recurrent network, neural network that overcome the vanishing gradient problem using memory cells. Each cell has three gates that regulate what information is retained or passed forwarded. For training, we use one hidden layer with 50 units, the Adam optimizer with a learning rate of 0.001, 100 EPOS, batch size is 32, and mean square error. As our loss function, we evaluate using R square, MAE, MSE, and RMSE on held out or tested. Here are some results. Uh, this is our key results. LSTM clearly perform ARIMA on every metric. R square score, ARIMA gives minus 0.15, meaning a poor fit, while LSTM achieves 0.96, an excellent fit. Mean absolute error dropped from 0.10 to 0.02, about 80% reduction. RMSE dropped from 0.23 to 0.05, about 78% reduction. So across every single metric, LSTM gives a dramatically better forecast of steam position. Now, in conclusion, LSTM significantly outperforms ARIMA for forecasting wall steam position. This framework can be integrated directly with Delta V DCS for continuous condition monitoring, where prediction deviation can trigger fault alarms and corrective actions. And the future work, we plan to extend this to hysteresis and backlash faults, explore hybrid ARIMA and LSTM, and attention-based models. So yeah, thank you so much for your time and attention.
Yes, thank you so much. So my question is, what are the advantage of using the data-driven model over the traditional physical-based model?
Yeah, so the advantages of using the data-driven model. Um, Uh, we use real-time health monitoring during active operation, reducing reliance on costly reactive or scheduled shutdown maintenance. Furthermore, deep learning model like LSTM can capture complex non-linear fault signatures and long-term sequential dependencies that traditional statistical or physical-based method often struggle to identify.
Okay.
Okay. Thank you so much.
Okay, thank you so much, Sarang. You can stop sharing your screen.
Yeah, yes.
Okay, so this was the last presentation for today. So, as we have come to the end of this session, I sincerely thank all our authors for their excellent presentations and their valuable contributions, all the participants for being an important part of this international conference. So, I truly hope that this session was insightful and engaging for everyone. On behalf of the entire team, we thank you for your continued support, not just for this edition, but all the previous editions of this conference. We look forward to welcoming you again in the next version in 2027 as well. All presenters will receive their digital certificates via email within 2 working days. And the publication will be live within 3 to 8 months. So we kindly request your cooperation with our team. I would also like to extend my sincere thanks to our session chair, Dr. Ishwari Raskar ma'am. Thank you so much for joining us. And this is a small token of appreciation on behalf of the team ICT4SD and the Global Knowledge Research Foundation and partners. Thank you all of you once again for your valuable presence. And before we officially wrap up, let's capture this conference as a quick memory. So I kindly request everybody to please turn on their cameras so that I can take a quick snapshot of this conference. Okay, 1 second. Okay, thank you so much everyone for joining. Stay safe, take care. Thank you, ma'am, for
Yes,
joining. Thank you.
thank you.